Hello everyone, welcome back to DigiRebar's Rebar detailing course. I'm Chen, your civil engineer instructor. In previous lesson, we walked through the precision report function. Whether you run a high-end automatic factory or just a basic workshop, you have learned how to calculate cutting list, control material waste, and generate procurement sheets. But today, we face another real headache on construction sites: rebar segmentation. Many junior engineers think we only split rebars because a single bar is too long to fit real stroke length. That is only half the story. There is also strict code requirement for lamp splice under ACI 318 clause 25.5.2. For tension bars, splice percentages must follow table 25.5.2.1. You cannot place all splices at the same section, otherwise your structure will fail good inspection. Improper rebar segmentation leads to rework, inspection rejection, or even hidden structural risks. This is exactly what Lesson 3 is about. We are going deep into the design menu. Two powerful features: segmented rebar detailing and variable rebar detailing function. Let's start with a typical example. Imagine we have one very long rebar, 25 meters long, with hooks on both ends. Obviously, you cannot buy a 25-meter rebar. We need to split it. Input this long rebar into your table. Select row and click the segmented rebar detailing. A configuration dialog pops up. Let's go through these settings one by one. Row 1 shows read-only length and quantity information. Row 2 gives you 3 different splice arrangement strategies, and I will explain where you would use each one in real projects. Interval ACS DECS. Half of the bars splice from left to right, and the other half from right to left. This is the most widely used method in real construction. It staggers splices naturally to satisfy ACI lamp splice percentage requirements. This is my go-to choice for most frame structure projects. Fix first length. The very first segment length is fixed by your menu input. Use this when your drawing explicitly defines the first bar dimension. Minimal scrap. This algorithm tries to minimize leftover stair waste. It reallocates length to maximize raw material use. But there is a key practical warning from my site experience. While it saves stair weight, it creates far more splice joints. More joints means more labor cost on site. For this reason, most projects avoid this model. Instead, we use the batch cutting report we learned in Lesson 2 to achieve material saving for the whole project. Moving down, raw material length is display only. If you need to change it, go back to global configuration we covered in Lesson 2. Shortest segment length. This sets your minimum allowed piece length. Do not make segments too short. Tiny short bars hard to transport, stack, and handle on site. This protects you from generating impractical precision data. Connection process. You can pick common joint types: serrating, welding, or lamp splicing. Welding includes single-sided and double-sided options. Based on your selection, fill in the joint dagger distance. You can input values in millimeters or multiples of bar diameter. this, you can preview the result for every splice method. Results are displayed in two rows, top and bottom, representing half of total quantity each. You are allowed to manually tweak preview results or export preview images. Once everything looks good, click Confirm. Notice your table now changed into parent-child row layout. Gray parent rows are non-editable, simplified summaries. Expand them, and you will see every individual segmented rebars as child rows. There are other segmentation strategies available. We won't demonstrate every single one in this lesson, but you can experiment on your own. Now, let's move to a more tricky real scenario, variable length rebar. Sometimes you meet this condition on project. You have a set of rebars where every piece has a gradually changing length. Their start or end points shift, following straight lines, sloped lines, or even curved geometry. Manual drawing these one by one is extremely tedious and error-prone. That is where variable rebar detailing saves your hours. We will start with a simple case, rebar length ranging from 3500 mm to 8500 mm with hooks on both ends. Select the rule. Open Design. Variable rebar detailing. First option, variable scale method, split or split and blanking. Since this bar set does not exceed row bar length 9 meter, we choose split. Next is split method, 2 modes for you. Number of group. You define how many final bar groups you want. For example, set total groups 23. You will get 23 distinct lengths from 3500 up to 8500. If you input 3 groups only, output will be 3500, 6000, and 8500. Gradiently length. You define the step size yourself. Example, length range from 35 to 8500. Total difference is 5000 mm. If you set gradient step equals 1000, fill your parameters, click Preview. You get 6 groups, 35, 45, 55, 65, 75, 8500. Inspect generated bar date. If no mistake, click Confirm, and it will populate all rows into your table automatically. What if your variable length bars are extra long? Take an example. Length varies 13,500 mm to 28,500 mm with hooks. Now check it and click button. Select split and blanking. This mode combines variable length generation together with automatic segmentation. Most parameters are identical to the segmented rebar function we covered earlier. Pay special attention to alignment method in the bottom right corner. Hover your mouse over the question mark icon to view the schematic diagram. Straight alignment. All bars are left aligned. Slash alignment. Start point shift along a slope. For instance, input 200, 150 to define your offset ruler. Arc alignment. Select this when your rebar starting edge follows an arc curve. Always refer to diagram to understand how geometry works. Alright, let's wrap up this lesson. Today, we learned 2 core design functions: regular rebar segmentation to satisfy row bar limits and SL lamp splice rulers. plus advanced variable rebar detailing for gradually changing bar geometry. I suggest you practice and create your first segmented rebar table manually. In our next lesson, we will move away from manual table input. We will show you how to import rebar data directly from Revit using the DigiRebar plugin. I'm Chen, a civil engineer from DigiRebar. Our workflows, I sure, come from real-side project experience, not pure textbook theory. If you run into software issues or have custom development requirements for your project, please reach out via DigiRebar.com, which you can handle complex rebar segmentation confidently. See you next lesson.